this is the construction diagram of this wind turbine. So wind turbine is installed on the tower, and also it includes the rotor blade and also the shaft. So the owners are tower, the wind turbine, rotor blade, and the shaft are installed. So inside this wind turbine, you can see the rotor shaft, also the low speed shaft, gearbox, and the high speed shaft. It also includes the blade. So the turbine blades are covered with the generator. The generators are produce the electricity. The generator electricity can be changed to the level by the transformer. So this is the energy conversion in the typical wind turbine. And in my popular wind turbine or the turbine says she there. I live out time summer swing to Lebanon. The lady she there. I let you not think how they are she there. Ella swing to a tower or data like today. I don't wind turbine. All my G like the camera, so not my road, she there, not a car, Kia, she there, not a car, no, a chain, million and lady, no, we would she there, now we chain Piao be there, Kia Boss, she there, now we take them in the Brady body, now we are generator, let us in another pity. A generator, Liberty, I mean, let's go out, total be there, any boa, and transform out, don't be lower there, no, level, do it. This is the sentence of the wind turbines. The placement or the setting of the wind system is extremely important. In order for the wind turbine system to effective, a relatively consistent wind flow is required. Also, inside the tree or the haze can interfere with the rotors. Because of this, the rotors are usually placed on the towers to take the advantage of the stronger the wind available higher up. Furthermore, wind speed varies with the temperature, season, and the time of the day. All these factors must be considered when choosing a site for the wind power generator. The amount of wind energy available at any location depends on the two sets of the factors. The factor A is the climate factors, including the time of the day, season, geographic location, topography, and the local weather. Number B is mechanical factors, including the diameter of the rotor and the type of the turbine. The utility scale and the wind farms must have access to the transmission lines to transport the energy. The wind farm developers may be obligated to install the extra equipment or the control systems in the wind farm to meet the technical standards set by the operation of the transmission line. Hello. ဒီလိုလေအားနဲ့ပတ်သက်တဲ့တာပိုင်ဆက်တွေကိုနော်တိဆောက်တဲ့နေရာမှာဆိုရင်အရေးကြီးတာနော်နေရာအနေထားအရေးကြီးတယ်။ဘာကြောင့်လဲဆိုတော့နော်အဲ့ဒီမှာနော်ဒီ wind turbine တွေကိုဝင်လာတဲ့လေအားဆိုရင်နော်ကိန်းတွေဖြစ်နေရမယ်။ဟိုတည်တည်ငြိမ်ငြိမ်နဲ့ပုံမှန်နော်တိုက်ခတ်နေရဖြစ်ဖို့အရေးကြီးတယ်။တော့တစ်ပင်တွေတောင်ကုန်းတွေအဲ့ဒါတွေကဆိုရင်ဒီ wind turbine ရဲ့လှုပ်ရှားမှုကိုလှုပ်ဆောင်ရမှုကိုအနှောက်အယှက်ပေးနိုင်တယ်။ဒါကြောင့်မလို့တာပိုင်ကိုတော့မြင့်မြင့်မှတင်ထားရတယ်မြင့်မြင့်တင်ထားခြင်းအပြင်တော့လေယာပို့ပြီးတော့ရနိုင်တယ်နောက်တစ်ခါလေရဲ့နော်အလျင်အားဆိုရင်အပူချိန်တွေရာသီဥတုတွေနောက်ပြီးတော့နေ့နာရီတွေနဲ့ပူနေပြီးတော့လည်းကွဲပြားနေတယ်ဒါကြောင့်မို့အဲ့ဒီအချက်တွေကိုနော် wind turbine တစ်ခုတည်ဆောက်တဲ့နေရာမှာဆိုရင်ထည့်သွင်းစဉ်းစားမှာဖြစ်တယ်အဲ့တော့ရရှိနိုင်တဲ့လေထုကစွမ်းအင်အားဆိုရင်အတိကအချက်နှစ်ပေါ်မူတည်နေတယ်နံပါတ် A ကတော့ရာသီဥတုနဲ့ပတ်သက်တဲ့အချက်တွေရာသီဥတုနဲ့ပတ်သက်တဲ့အချက်တွေဘယ်နေ့မှာဘယ်အချိန်မှာလဲနော်နောက်ကရာသီဥတုနော်နောက်ပြီးတော့နေရာအနေထားနောက်တစ်ခါနော်သက်ဆိုင်ရာတီးစားထားတဲ့နေရာရဲ့နေ့စဉ်နဲ့အမျှနော်ရာသီဥတုအဲ့ဒီအချက်တွေပေါ်မူတည်နေတယ်ထို့အတူပဲသူစက်မှုဆိုင်ရာနော်အချက်လက်တွေဥမာဖြင့်ဒီလေပတ်နေတဲ့နော်ဒလက်ကစုစုပေါင်းအချင်းဘယ်လောက်ရှိမလဲနောက်ပြီးဘယ်လိုတာပိုင်မျိုးစားသုံးမလဲဆိုတာကိုအဲ့ဒါအရေးကြီးတာဖြစ်တယ်အဲ့တော့ဒီလိုwind turbine တရားဆိုရင်ဆက်စစ်တအားထုတ်လုပ်ပြီးမှဆက်စစ်တအားတည်ယူပို့ဆောင်လာဖြစ်တယ်ဒါကြောင့်မို့အဲ့ဒီတည်ယူပို့ဆောင်တဲ့ power line နဲ့ပတ်သက်တဲ့အချက်လက်တွေကိုလည်းထည့်သွင်းစဉ်းစားရမယ်အဲ့ဒီအချက်လက်တွေနဲ့ကိုက်ညီအောင်လို့ဒီ wind turbine တွေ wind turbine ရထုတ်တဲ့ generator တွေကထုတ်ပေးတဲ့ဆက်စစ်ကိုပြုပြင်ပြောင်းလဲဖို့လည်းအရေးကြီးတဲ့အချက်ဖြစ်တယ်This diagram you can see the offshore wind farms and the onshore wind farms. ဒီပုံမှာပြထားတာပါလဲဆိုရင်တော့ပင်လယ်ထဲမှာရှိတဲ့လေအားလျှပ်စစ်စနစ်တွေနောက်ပြီးတော့ကုန်းပေါ်မှာရှိတဲ့လေအားလျှပ်စစ်စနစ်တွေအဲ့ဒါတွေကို constraint for the wind turbine. So there is a number of the planning related issues that may make it difficult for you to install turbine on your site, and it was wise to ensure that you are not going to fall on the needs these people are proceeding. The military installation, avoid the installation, especially if it is an Air Force base or the communication centers approximately to the Bay area. When the housing estate are the concerned, ideally consider a distance of at least 200 meter to 300 meter, depending on the size of the turbine. A designated area or the least surveillance. National parks or the area of the outstanding national beauty are more difficult to satisfy the local planning officer to install a wind turbine on it or the near it. So those are the planning constraints for the wind turbine. And all the Liana Patate turbine set to go for this out. အရေးကြီးတဲ့အချက်လက်တွေကိုရှောင်ရှားမှာဖြစ်တဲ့စစ်ဖက်ဆိုင်ရာအဆောက်အဦတွေဖူးပြီးလေတပ်အဆောက်အဦတွေဆက်သွယ်ရေးအဆောက်အဦတွေကိုရှောင်ရှားရမယ်နောက်ပြီးတော့ဒီလိုတိဆောက်နေတဲ့ဒီလိုလူနေတဲ့နေရာတွေကလည်းအနည်းဆုံး200 meter နဲ့300 meter အကွာအဝေးမှာဆိုရင်ဒီ wind farm တွေကိုတိဆောက်ဖို့လိုတယ်နောက်တစ်ခါnational park တွေအထူးတိဆောက်ထားတဲ့တဘာဝအလှအပတွေအဲ့လိုနေရာတွေမှာလည်းပဲဒီ wind farm တွေကိုတိဆောက်မှုကိုရှောင်ရှားဖို့လိုတယ် The wind farm design. This is important if the project is a wind farm, wind data is combined with the topographic information to design the wind farm. Engineers use this data to model the wind flow, turbine performance, sound levels, and other parameters to optimize the location of the wind turbines. They also design and assess roads, turbine foundation, and the local electric network, as well as the connection to the electricity grid. So that in this you can see the wind farms are installed, so that the prevalence winds are coming to the wind farm, and also there's the diameter of the wind turbine, and the distance between the wind farm, one turbine to another turbine must be the 70 to the 40. So this is the allocation and the design of the wind farm. Soဒါထုတ်ပေးတဲ့အဆောက်အဦတွေကိုဒီလိုနေရာကိုတိဆောက်တဲ့အခါမှာဆိုရင်အဓိကအချက်ပါဆိုရင်ဒီလိုလေးနဲ့ပတ်သက်တဲ့အချက်လက်တွေသိဖို့လိုတယ်လေးနဲ့ပတ်သက်မှာလေးတွေအားဆိုဘယ်လိုတက်တယ်လဲယာတီဥလိုအခြေအနေမျိုးပြီးတော့ဘယ်လိုတက်တယ်လဲဘယ်လိုတိုက်တယ်လဲအဲ့ဒီအချက်တွေသိဖို့လိုတယ်ဒါမှမဟုတ်အဲ့ဒီအချက်လက်တွေကိုမူတည်ပြီးမှလေးဘယ်လောက်နှုံးနဲ့တိုက်တယ်လဲနောက်ပြီးတော့ဒေတာပိုင်းတွေကဘယ်လိုအလုပ်လုပ်ဆောင်တယ်လဲအတန်ဘယ်လောက်ထွက်တယ်လဲအဲ့ဒီအချက်တွေကိုကြည့်ရမယ်ကြည့်ပြီးတော့မှတင့်တော်သလိုဒီ wind turbine တွေကိုတိဆောက်မှာဖြစ်တယ်အဲ့တော့ပုံမှာပြထားတဲ့အတိုင်းပဲဒီမှာလေလာနေတဲ့အဲ့မှာ wind turbine တွေကဆိုရင်သူ delay ကသူအချင်းအားဆိုရင်ဒီဖြစ်တဲ့ wind turbine တစ်ခုနဲ့တစ်ခု40နဲ့70ကိုကွာခြားဖို့လိုတယ်အဲ့ဒီအချက်တွေလုပ်ရမယ်ဒါကြောင့်မလို့အဲ့ဒီအချက်တွေလုပ်တဲ့အခါမှာဆိုရင်ဒီ turbine တွေစီကိုရောက်ဖို့အတွက်လမ်းတွေဆောက်ဖို့လိုတယ်နောက်ပြီးလိုအပ်တဲ့အောက်ခံအဆောက်အဦတွေဆောက်ဖို့လိုတယ်တင့်တော်တဲ့ဖျက်စစ်ဒါအားတည်ယူပို့ဆောင်ရေးစနစ်တွေလည်းတည်ဆောက်ဖို့လိုတယ် We also have to concern about the economic and the financial evaluation. To prove the economic viability of the project in order to raise the funds to pay the wind farm, on one hand, there is a need to estimate the cost of the turbines and their installation, as well as the roads, electrical system, operation and maintenance, etc. And on the other hand, there is a need to estimate the income from the energy production of the wind farm over the lifetime of the project. If there is a net profit, the project has a good chance to succeed. The site preparation, pay as roads and clear the areas where the turbines will be erected. Then prepare the foundations to do the excavation, followed by the installing the networks and the pouring the concrete. The construction, the wind turbine parts are manufactured and pre-assembled into the main components at the factory, then ship it to the wind farm site where the final assemblies will take place. When all components have been received, the assembly can take place. A crane is used to erect the tower and install the necklace and the rotor, which is half and the brakes. On the ground, the electric connection network is installed and connected to the grid through the substation. The commissioning. Finally, the wind turbine is tested. All components are calibrated on the site and verified against the supplier specifications before becoming fully optional. ဒီမှာပြလိုက်အချက်တွေဆိုရင်ဒီ wind turbine နဲ့ပတ်သက်တဲ့စဉ်းစားမယ်အချက်တွေဖြစ်တယ်ပထမဦးဆုံးစီးပွားရေးရခံမှန်းရမယ်ခံမှန်းတဲ့ခါမှာဆိုရင်ဒီ wind farm တခုဒီဆောက်ဖို့ရတာဆိုရင် နော်ဒီလိုတာပိုင်ကိုဝယ်ဖို့တဲ့ဘယ်လောက်ကုန်ရတယ်လဲသူတို့တင်တက်နော်တက်ဆင်ဖို့လည်းဘယ်လောက်ကုန်ရတယ်လဲနောက်ပြီးအဲ့ဒီနေရာကိုလမ်းတွေဖောက်ရမယ်လျှက်စစ်စနစ်ကိုတက်ဆင်ရမယ်နောက်ပြီးတော့ဆောင်ရွက်လုပ်ရှားတာတွေနောက်ပြီးတော့ပြုပြင်ထိန်းသိမ်းတာတွေကုန်ကြတဲ့စိတ်ကိုတွဲဖို့လိုတယ်နောက်တစ်ခါအဲ့ဒီဝင်းဖန်ကနေပြီးထုတ်လုပ်လိုက်တဲ့နော်လျှက်စစ်စွမ်းအင်ကနေပြီးတော့ရောင်းချလို့ရမှာဘယ်လောက်နော်အမြတ်ငွေရမလဲအဲ့ရတဲ့ငွေနဲ့နော်အဲ့ဒီကုန်ကြမှုနဲ့ကိုနှိုင်းရှင်ရမယ်ရှင်ပြီးတော့ကဒီ project ရဲ့တက်တန်းကာလမှာဆိုရင်အများဆုံးရမယ်ဆိုရင်ဒီလိုဒီ project ကအောင်မြင်ဖို့အတွက်အလားအလာကောင်းတယ်အဲ့တော့တွက်ချက်ပြီးတဲ့အခါမှာကြာရင်တော့ဒီလိုအပ်တဲ့ဒီတိဆောက်မဲ့နေရာကိုပြုပြင်တာပြင်ဆင်ရမယ်အဲ့မှာဆိုရင်အဲ့ဒီနေရာမှာရှင်းနေရမယ်နောက်ပြီးအဲ့တာပိုင်းတွေတိဆောက်မဲ့နေရာမှာရှင်းနေရမယ်လမ်းတွေဖောက်ရမယ်နောက်ပြီးတော့အုံမြစ်တွေချရမယ်နောက်ပြီးတူဝဖော်ရမယ်နောက်ပြီးတော့ကုန်ကလေးတွေလောင်းရမယ်နောက်ပြီးတော့ဒီပုံစံတွေကိုတိဆောက်မှာဖြစ်တယ်တော့တိဆောက်တဲ့အခါမှာဆိုရင်တော့ဝင်းတာပိုင်းမှာရှိတဲ့အစိပ်ပိုင်းတွေဆိုရင်စက်ရုံမှာတွေအစင်းနဲ့တက်ဆင်ပြီးတာဖြစ်တယ်အဲ့ဒီအစိပ်ပိုင်းတွေကိုလုံးကိုယူသွားပြီးတော့တက်ဆင်မဲ့နေရာကိုယူရမယ်ယူသွားပြီးကရိန်းကိုအသုံးပြုပြီးမှတက်ဆင်ရမှာဖြစ်တယ်အဲ့လိုကရိန်းကိုအသုံးပြုပြီးတော့တက်ဆင်ပြီးတော့မှခါရီသူ့မှာဆိုရင်တော့ half day blade တွေကိုတက်ဆင်ရမယ်တက်ဆင်ပြီးမှဆက်စစ်ဆိုင်ရာဆက်သွယ်မှုတွေပြုလုပ်ရမယ်ပြုလုပ်ပြီးတော့မှတော့ဒီဆရာစစ်ပတ်လန်းကိုဆက်သွယ်ရမှာဖြစ်တယ်အဲ့ဒီချက်တွေကလည်းပဲတိဆောက်ဖို့အတွက်လိုအပ်တာဖြစ်တယ်နောက်ဆုံးချိန်နေကြတော့အဲ့ဒီစိတ်ပိုင်းတွေတက်ပြီးတော့မှအဲ့ဒီစိတ်ပိုင်းတွေကိုနော်ချိန်ညှိရမယ်နောက်ပြီးတော့စမ်းသပ်ရမယ်နောက်တတ်မှတ်တဲ့ထုတ်လုပ်ပေးတဲ့လူရဲ့စာရေးစာရုံးနဲ့ကိုက်ညီမကြီးကိုစစ်ဆေးရမယ်ပြီးတော့မှအဲ့ဒီဝင်းဖန်ကဒီတာပိုင်စနစ်တရားဆိုရင်ပြည့်ပြည့်ဝဝအသုံးပြုလို့That way, the wind turbines rely on the movement of the rotor affected by the wind to rotate the generator and make the electricity. Virtually, everything with the moving parts will make the same sound, and the wind turbines are no exception. Turbines are established and well-developed technology. The well-designed wind turbines are generally quiet in operation, and combined with the noise of the road traffic, train, aircraft, and the construction activities. The noise from the wind turbine is relatively low. Outside, there's a nearest house which are at least a half a mile away, and more often the farther, the sound of the wind turbine generating electricity likely to be about the same level as the noise of the leaves rustling or the generator breeze. This is similar to the sound level inside a typical living room with the gas fire switch on, or the reading room in the library, or the combinated quiet air conditioned office. Then you can see there's a source of the activities and the indicate noise level decibel. So those are there's a table. You can see the kind of this activity and the noise level. So ဒီလိုလေအားနဲ့ပတ်သက်တဲ့တာပိုင်ဆက်တရားဆိုရင်ဒီမှာရိုတာရှိတဲ့ရိုတာဆိုရင်လေအားနဲ့ရိုတာဒလက်တွေကိုလဲပြီးတော့မှဆိုရင်ဒါဂျင်နေတာလဲပြီးထုတ်လို့ပေးတာဖြစ်တယ်ဒါကြောင့်မလို့အဲ့ဒီအစိပ်ပိုင်းတွေကလေအတန်ထွက်တယ်ဒါပေမဲ့အဲ့ဒီအတန်ကတော့ပြိတ်ပြီးတော့အရေးပြိတ်ပြီးတော့မမြင်လာဘူးဘာကြောင့်လဲဆိုတော့အမတန်ကောင်းတဲ့ဤပညာကိုအသုံးပြုပြီးထုတ်လို့ထားတဲ့အတွက်ဖြစ်တယ်အဲ့တော့ဒီအဲ့အတန်ဆိုရင်ဒါရထားတွေလေရင်ပြန်တွေဆောက်လုပ်ရေးစနစ်တွေအဲ့ဒီမှာသုံးတဲ့အတန်နဲ့စာရင်အများကြီးနှိမ့်ကြတာတွေ့ရမှာဖြစ်တယ်အဲ့တော့ဒီလိုဝင်းဖန်တဲ့တစ်ခုရဲ့တော့မိုင်ဝက်တော့မှရှိတဲ့နေရာမှာဆိုရင်အဲ့အတန်ဆိုရင်ဘယ်တော့မှပြိတ်ပြီးတော့လေလိုက်တဲ့အတန်တော့ပဲကြားပါဖြစ်တယ်ပုံမှန်ကြည့်တဲ့အခါမှာဆိုရင်ဒီမှာတရားပြထားတယ်တရားမှာဆိုရင်ဘလို့လှုပ်ဆောင်မှုတွေလုပ်မယ်အဲ့ဒါအဲ့ဒီလှုပ်ဆောင်မှုတွေနဲ့ပတ်သက်ပြီးတော့ထွက်လာတဲ့အတန်ကိုလည်းပဲဒီဇာတ်မှာပြထားတာတွေ့ရမှာဖြစ်တယ်We will talk about the theory of the wind energy. The principal concern with converting the potential energy of fluid into the useful power lies on the three basic fundamentals: conservation of mass, energy, and the momentum. So it is useful to discuss this before examining the operation of the wind turbines. Firstly, we talk about the conservation of mass. The continuity equation applies the principle of the conservation of mass to the fluid flow. Consider the fluid flowing through the phase conjugate having one inlet and the other outlet. So in this case, inlet the velocity is V1 and the inlet area is A1 and there's this with the pressure P1 and the densities are ρ1. The outlets are areas of A2, the pressure P2, and there's a density ρ2 and the velocity V2. So this is the conservation of mass of the fluids are flowing the inlet part. So the inlet mass is equal to outlet mass. This is the conservation of the mass. The wind energy နဲ့လေတိုက်ကိုသုံးပြီးတော့မှဒီစွမ်းရည်ထုတ်လုပ်တဲ့အခါမှာဆိုရင်အရေးကြီးတဲ့အချက်၃ချက်ကိုစဉ်းစားရမှာဖြစ်တယ်။ဓာတ်စုတည်မြဲတဲ့ဓာတ်ထုကလည်းတည်မြဲရမယ်။စွမ်းရည်ကလည်းတည်မြဲရမယ်။အဟုန်ကလည်းတည်မြဲရမယ်။အဲ့ဒီအချက်၃ချက်ကဆိုအဓိကကြားတဲ့အချက်ဖြစ်တယ်။ဒါပေမဲ့ဓာတ်စုတည်မြဲတဲ့အခါမှာစဉ်းစားတဲ့အခါမှာဆိုတော့ဒီဝင်လာတဲ့ငွေရည်ရဲ့ဓာတ်ထုဒီထွက်သွားတဲ့ငွေရည်ရဲ့ဓာတ်ထုနဲ့ညီတယ်။အဲ့မှာပုံမှန်ဖော်ပြထားတဲ့အတိုင်းပဲနော်ဝင်လာတဲ့ငွေရည်ရဲ့ PR ဒီ P1 ငွေရည်ရဲ့အပြင်ဒီ V1 အဲ့ဒီ area ဒီ A1 နဲ့သိသိချင်းဒီက ρ1 ဖြစ်တယ်ထွက်လာတဲ့ငွေရည်ရဲ့နော် I think the V2 now be a PR the P2 area the A2 net division the road to today. A winner at some machine there. Try to do time, Biroma, the low. And if the flow is steady and no accumulation of the fluid within the control volume, then the rate of the fluid flow at the entry must be equal to the rate of the fluid flow at the exit for the mass conservation. If the low cross-sectional area and the fluids have passes travel a distance, dr, so in this case flow rates it can be given as Vi is equal to AD divided by dt. So d by dt is a velocity, so the Vi is the V multiplied A. And therefore we write down the equations that all the mass are constant, so the rho 1 A1 V1 equal to rho 2 A2 V2. So this is for the constant mass equation. The next one will be the conservation of the energy. The conservation of the energy is necessitates that total energy of the fluids remains constant. However, there can be the transforming from the one form to the another. These are the three forms on the nose thermal energy for the fluids at any given point. So kinetic energy due to the motion of the fluid, potential energy due to the potential elevation above the dead arm, and the pressure energy due to the absolute pressure of the fluids at the dead point. Those are these energy have to be conserved. All energy combinations at the inlet and outlet must be equal. And not only that, season no season no was a tiny in the Kama so in below imagine a yellow yard or Trala and imagine the VI is going to AD by DD so imagine a yellow yard. I must say season no was a VFJ AR D by DD or season at the end. And then the vehicle the velocity area and whom you are needed. Jammo away at Ramashi de no the long way in the Kuya try to the 2 years so that way row A1 V1 D row A2 row 1 A1 V1 row 2 A2 V2 needed. And now the Chagado swine in Tiniamu Niamachide. The swine Tiniamu Niamas swing. Will others we swine in a Trottel and we swine and Yami. Ekamase, the swine will blow you since I yard, but I'm also a swine. The kinetic energy local and asking Yeria Yushani Tamado, you swine sheet. The potential energy are at the swine. The sheet and the Abo Mudio at the swine sheet. The pressure energy. The pressure means the PR swine. The way I pay only the PR moody Roma swine, the sheet, Eddie swine, Romeo bounty, that Tiniame, swine the Pongan to Kuan to Kuo Piano Yare, Diamond Pongan Domime, no, Suba swine, the Alobon or Tini. This one is a conservation of the momentum. Consider it down on the length L cross sectional area A, surface area AS. So cross sectional area AC and surface area AS. In which a fluid of the density rho is flowing at the mean velocity V. The forces acting on the segment of the duct are that due to the pressure difference and that due to the friction and the walls in contact with the wind, in contact with the fluid. So if the acceleration of the fluid is 0, the net force acting on the element must be 0. Hence, P1 minus P2 multiplied AC is equal to F rho V squared divided by 2. Multiplied AS equal to 0. So in this case, P1 minus P2 equal to rho G HF, and HF equal to F multiplied AS divided by AC multiplied V squared divided by 2G. The 40 pi's are AS by AC equal to pi D divided by pi D squared divided by 4. So you call the 4L divided by D, and on this case, HF is the 4L divided by D multiplied the V squared divided by 2G. So this equation is a conservation of the momentum. And another one, so in the pipeline to push the pipeline, so now, Piabai area AS, AC Roma, the Mianabi area AS, Elo, not too much at the Vision, Roshi, and also a year swing, season as I think Venus is in it. Elo Eddie, no, as a moment, Giant, PR, the Aswing, Guadamu, Moody, Alliance, season is up to it. At Yamlo, P1 minus P2 into AC equal to F. Rho V squared by 2 multiplied AS equal to 0. So when you imagine a 0 yame, P1 minus P2 as a rho G multiplied HF and Mide, and HF as F multiplied AS divided by AC multiplied V squared by 2G and Mide. Now by line so AS by AC as by D divided by D squared by 4 Peter 4 divided by D. So when you imagine a 0 yame, Eddie Kama so HF 4 divided by D multiplied V squared by 2G. So when you imagine a 4 Yard. And our balance in Darcy formula. Why is the ideas of wind power calculation? So in theory, wind power P is calculated by following the general equation. So in this case, P equal to CP multiplied half multiplied rho multiplied A multiplied V power Q. So this equation. So in this case, CP is a power coefficient. Rho is a density of the incoming air the sway area of the rotor and the V is the velocity of the wind. So those things are ideal wind power calculation of the wind turbine. The wind turbine to be there, later by a to be there, layers are swine ingo, swine layers are power of Luna in a Toluya, so P equal to CB multiplying half row, AV power 3 so in Imagine Toluya, Edima swing, CB swing, power gain the pit, Tuaro, the Lare layer. Now, baby Jim today, Earo Eddie, Rodae, no, Liu, down the area, Pibro, Viaro, a Ledue, a same today, a Moody Loma, layer power, Galuya. This one is a theory of the wind turbines. The winds may extract the power from the wind by slowing down the wind. At the same state, the rotor obviously produces no power. And at a very high rotational speed, the air is more or less blocked by the rotor and against no power to produce. The power produced by the wind turbine is a net kinetic energy chain across the wind turbine. And from the initial air velocity of V1 to the turbine exit air velocity of V2. So that can be calculated. The P is equal to the half H M multiplied V1 square minus V2 square. So this is the wind power produced by the wind. Wind turbine machi the kama swing the wind machi the power the wind la the leo the ashin fnewa the line fnewa the line bioma H no ashin wind a trend no swing the kukwebia chana mu moody bioma a swing and be turbine the little slab it up chit so leya nyine the swing of the turbine ba power am travel and not the car baby ole no so near I see thing Nialoni liberty, the winner Leo, the Rodalia Navio, not Tatiwana, Pit, Jamlo Power Toma, Pio, Jamlo, Tawa, no little name was in winner lady, not the winner lady, no. I know who swine in China, you is in China, Moody Yoma, a China, the Tower in the little Levido, Leo Tobina today. And then the winner as in the velocity V1 people, 12 lay a loss, as in the V2 there, power total of PKM, PKM half multiply, and multiply V1 square minus V2 square in a 12 yard. I must say, air swing down, lay a traduce V1 and V2 are winning at Tremachide, lady as in the Pijalo, not. Kinetic energy is related to the moment of the velocity body in the question. So KE is a flywheel effect and the energy of water flowing in the stream. So kinetic energy half multiplied mass multiplied velocity square. So in this case FK is equal to half multiplied mass multiplied V square. The water stream in the river flowing at the velocity of the 2 meters per second. In this case kinetic energy can be calculated half multiplied mass multiplied velocity square. So half multiplied 1 multiplied 2 square. So you got a 2 joule per kilogram. The electrical energy, the diode energy is the simplest associated with electromaterial electrical energy. It is in the two form. Who either come out in the swine, the Yabutu to a Yusan, Pima today, or Yusan in the Nabai meow, Dradu of meow. No, at least Natan and needed. FK equal to half multiply, mass multiply, V square and needed. Here must be season the year swing below, not 2 meters per second and season the swing. I'm now 1 kilogram she the year. So a US one in the blue 12 yards, half multiply, mass multiply, velocity square, so half multiply 1 multiply 2 square, so there are 2 joule per kilogram. So just is swinging out of the electronic use and moody, just is swinging out of Ponga community. This diagram is you see this overview diagram of the wind turbine and all the equipment and also the components. And you must check out the layers, there's a turbine, bomb it too much, say by the net, too much, say by the top the city. Then we're talking about the steps to planning and the building and the wind farm. There are many stages of the development before the wind turbine or the farm can be approached and built. One is site has been selected for its goods over all the position. What begins on serve as a main task. The first is a consultation with the local authority. It is extremely important to contact the local authority in the area where the turbine is considered before committing any time or the cost. Engage them early in the planning process, answer any questions and or the concerns that they might have, and keep an open dialogue with them throughout the whole development. Another thing is a consultation with the public near the site. The local community, who are likely to be affected by the proposal must be met to the present the project, solicit their feedback and seek their vote. And advertisement in the local paper would be a good idea to inform the general public and invite them for a discussion and a debate. And land acquisition. Early in the process, developers, it is, if not already the owners or the themselves, usually they approach the landowners to negotiate the option agreements to use their land. As the projects are progress, the developers will seek to convert the options into farm and the land lease agreements. The wind assessment. Another very important step is assessing the wind rate resource. Scientists and engineers use meteorological mass to measure the wind speed and other climate conditions for at least 1 year. The data is then used to estimate how much energy the wind farm will produce. It is often assumed that this has to be carried out before any serious consideration is planned. Those are important steps for the planning and the building of the wind farm. And the other part that is just the total Senegal, Tito de Kamaswing, a year actually Sinzama Pede. But also, Dilo Tabaini, Define Golo, Matisaki Mande, Bay Checo, Loam, but also Pesaya, no, Anna Bainine, Dirasa, Anna Bainine, Taimiame, a Davine Kamaswing, Dilo. Project Masagima to go at the Taimiame, Taimio to do leve, the Sasa in Siman, Nide Chima, project of Siman in the Chima swing, or to do Satwayame, to do Mimian or Piame, or to do it, not the Ritame, Chetuguani, your Shinin Biame, and not to do it. The project to Kulo, the sum of the Kuloma, to make a radio who are Yeji, Chepide. Naruga, I disarmed Neanama, she did Ludunele, not Taimiama Pide, a Luduas, Ludue, not Dudo, a Jangame, to do it, no, to Piamio, to do Piami Piore, Chete, to do it, no, Piami Pijame, to do it, Tokamule, Yashu Lode, Desaya, not Dela Saya, the Rinzama, so in Jina, Ludo, Bibo, Luade. And Naruga, I, the wind found the Sabo Twe, Mio Yayuame, and on Mio Yayu de Kamaswing, the Mio ascended the Comuniama Pine, Mebusui, Desaya, no Mia Shinene, Hinayame, Hinayong, Mio, Nabo Dwe, no, the body Chede, Sajo Sadanio, not Losama Chede. And Naruga Bobi Yida, so the outside Leo, Sisebo Lode. The Leo Sisida Kamaswing Dimo, not Paper Binyashin engineer, they are swing Leo, he as in Taindame, the Sha, Yadu Chini, Taindame, 8 Taindamu, a chair let you, the Nilo, the Losame, the Pinal Losam Bidoma, the Lao Swine, told Roman, so loud, Twachame, and Twacha Bidoma, no, Tilo, Tasaya, Davine, the Sassin, the Tisao, Yama, Chitty.